Good morning, good evening, good afternoon, folks, from wherever you're joining in. My name is Prithvi Raj, and I welcome you all to the first community call for this year, the Litmus Chaos-Community-Sync-up January 2023. And again, once again, it was an amazing year last year for us, from incubation to all that we achieved as a community at KubeCons, at various conferences in terms of development, and then we look forward to another amazing year. There's a lot coming up. We are hopeful that this year we can see a lot develop with Litmus Chaos 3.0. There are a couple of amazing KubeCons coming up, as well as there's a lot to look forward to. Overall, as a community, we hope that this year we have more end users coming up, sharing out their amazing chaos engineering stories. And obviously, we're joining various community events, conferences to just deliver a lot more on their journey with Litmus Chaos. So without any further ado, I would like to share the agenda that we have for today. And let me just share my screen. I hope my screen is visible. So obviously, we'll just start with a quick introduction of new members on the call. A quick community roundup. I think last month we talked about the community review, what has happened over the period of 2022, the latest videos that we had. And this community roundup will be more about Litmus Chaos participation in Chaos Carnival. But before that, I think we have one of our new members, Abdul, who's joined in. Maybe Abdul can just introduce himself to the community, and then we can quickly move through the community roundup.
Yeah, sure. Myself, Abdul Rauf, and I am actually working with one of the companies here, wherein we actually do the kiosk testing for the environment. So I have been working on it. So I was really looking to join the SICUM call for that reason. Like, what are the improvements we will be having, and what is actually the roadmap? So yeah, I think that's it.
Thanks a lot, Abdul, for joining in. We look forward to hearing from you more during the Q&A session. And we have a couple of updates today from Shubham, who will be presenting on the improved debuggability. And obviously, Akash Srivastav, he'll be talking about the agent Helm chart. So we'll wait for that. But a quick community roundup. I think the last 1 month has obviously, after coming back from holidays, it's been busy, and we see a lot of questions coming up in the community. But mostly or majorly, it's been about Chaos Carnival. So as you can see, Litmus Community is one of the community partners for Chaos Carnival 2023, and we'll see a lot more on Litmus Chaos in the conference. The conference is on the 15th and 16th of March 2023. I'll share the link to the conference in chat. And obviously, coming back to its third edition, we'll have 4 keynotes this time around, a couple of workshops or more, a chaos panel discussion, and the CFPs are open. So you can obviously submit a talk, especially on Litmus Chaos. There's a lot of Litmus Chaos that will feature in the conference. And if you are interested to just be a part, then just join in. You can register for free at chaoscarnival.io and be a part of the conference. That sums up a lot that's been happening in the chaos engineering community, and we look forward to, I mean, it's a virtual conference. You can attend for free. So we look forward to a lot more happening on the March 15th and 16th at Chaos Carnival. So without any further ado, I will allow Shubham to take the floor, and Shubham, you can go ahead with your demo.
Thanks, Prithvi. Hi, everyone. I'm sharing my screen. So as part of this demo, I will talk about our new addition to the fail step, also the probe description. So we have added like root cause inside the fail step. We have improved our fail step, and also we are logging the stack trace into the log as well. So you can better debug the failure now. Also inside the probe, we are adding the probe description, which will tell you about the, I mean, in case of a positive as well as in case of a negative, you will find the reason of the probe failure. So I will just run a HTTP chaos experiment to show you, I mean, how we are, I will fail the experiments. I will just go through the schema and then I will explain this. So I will create a new scenario. I've created a template. I mean, existing templates. I'm using the template for now. And as part of this, I'm using Nginx pod as a target application, which is running in Shubham namespace. So I have selected the application, and I'm using two probes here. So one probe is KTest probe, which is running in a edge mode. It will run in the beginning and in the end of experiment, and it will just check that there should be a pod running with this app is equal to nginx name labeled in the Shubham namespace, and I'm using operation present, and I will run this in a edge mode, so it will verify in the beginning and in the end of the experiment. So because I have already pod is running in that namespace, so it should be, it should pass. The next probe is HTTP probe. So here I'm running it on chaos mode. So I will run during the chaos. And here I'm just providing the service URL of the Nginx application, which is my target application, in which I will inject the HTTP status fault. And here I'm just verifying that the response code should be 200. But as part of chaos, I'm changing its response to the 400. So this probe should fail. So if we will move to the chaos tunable, so I'm running this for 40 seconds and with a 5 second interval, and the status code should be 400. So I'm scheduling the experiment. I think we can open. So my application is running in Shubham namespace. So you can see the application is here, and we can see pod delete experiment pod is started. Okay, so there are a lot of pods. Okay, so it is already started. So yeah. So if we want to check this, so I mean, we can also check the status code as well. So I can just port forward it if you want. I think the experiment is already completed. Okay. So we can see the experiment is fail. We can describe the chaos result and check what is the failure. So here you can see we have added the experiment is fail, and we can see we have added the fail step here. So and this fail step have few attributes. So one is error code. So in error code we are creating a specific error code for each type of error. So this is a std probe error, so that's why we like this is std probe error. I mean, we have lot of error code, so we will also document this. So based on the error code, you can also find the what is the possible fail reason, or what can be the workaround you can do. So that we will do later, but for now we have a specific error codes. So next is the phase, in which phase of the experiment this experiment is failed. So this experiment is failed in chaos injection, and the reason is the root cause of the failure. So here you can see probe responded with an invalid output. Actual value 400 is not equal to the expected value 200. So because we have injected the http status code error, and we are changing its response status code to 400, but it should be 200. So that's why this probe is failed, and the target is the probe name, because of which the experiment is failed. Also you can see the inside the probes as well, you can see the probe description. So this is the probe description of the KTest probe, which is running in the beginning and in the end of experiment, which is checking the nginx pod should be in running state. So because the nginx pod is keep on running state in the before and end, so we can see probe is successfully performed the present operation on Kubernetes resource, and this probe is passed. And the second probe, which is failed because we were expecting 200 code, and it gives us a 400 code. So you can see that in the description as well. So the probe responded with the invalid output, and actual value is 400, but it should be 200. So this probe is also failed. So now with these fail step and probe description, you can directly find the root cause of the failure. And if you want to, so this is for the probe case. So even in, if it is not a if it is not a SLO validation error, if it is a normal if you have provided a wrong socket path, or if you have provided any configuration mismatch, in those cases also the experiment will fail, and the corresponding fail step should be there. So I already have a chaos result, which is failed because the target application was not there. So the app label which I provided is a wrong. So we can also I can also show you that result. I think this is the result. So in this, we can see the error code is status check error, because we are checking the status of the pod, and at that time we got that error. So, and you can see the phase is pre-chaos. In the beginning of the chaos, we got this error, and the reason is no pod found with matching labels. So and inside the target, we are providing pod label is app is equal to nginx1, but the label of the other pod is app is equal to nginx. So the label is wrong, and the namespace is Shubham. So in this namespace with this label, there is no application. So that's why the experiment was failed. And because this probe is running in on chaos, and experiment is failed in the start of test only, so that's why the probe is not executed. So we are getting the description as either probe is not executed or not evaluated. So this is one case. Also, if you want to know, if you want to debug it more, you can also see the whole status in the logs as well. So I can show you this logs as well for this experiment run. So here you can see the whole stack trace. So this was failed in application status check, and the whole path, the function where it is failing, and all the path and everything you will get here. So this is the complete stack trace, which you can find in a log for the debugging. So yeah, so this is our like this is came in this release 2.3 sorry 3.0.0 beta 3. So from this release onward, you can use these two features. So yeah, this is all about the field step and the probe description. So I'm open for the questions.
Shubham, I have a question. Suppose if we have an environment where I will give you a different scenario. We have, say, for example, 2 nodes in that cluster, and I am using a node drain, right? So I'm draining those nodes, but I am using that for both of those nodes. Can we get that logs from there as well?
So okay. So first, so if I understand correct, you are saying you have a 2 node and you are draining both the node.
Correct. So what will
So
happen actually? What will be the behavior of that? I mean, that time.
okay, so first thing is right now in node drain experiment, we are not supporting, because the blast rate is high, so we are not supporting multiple node at a time. But suppose we are like, let's assume we can do that. So in that case, because there is no node is in ready state, right? So because there is no node, so the pod will not schedule on any node. So in that case, that it will be a failover.
Okay.
Because to run the experiment or to run anything, right, we need a node where it should run.
Correct. Yeah, where the pod should be scheduled.
Yeah.
I was just wondering, like, if we can have those logs available, or yeah, and that's just yeah.
So just to add, Abdul, in such cases where you want multiple nodes to be drained, you have the option of ensuring that the chaos pods get scheduled on a different node. So if, let's say, you want to train 2 nodes of a 3-node setup, you can choose that all the experiment pods are launched only on the 3rd node, which you've reserved for running Litmus. You can specify that via some topology attributes during the workflow creation. You can specify node selectors, or you can even specify tolerations, etc. Some of these attributes can be provided to force Litmus pods, experiment pods, into the node which you've dedicated to run these pods, and from there you can train the other nodes. So that's also possible.
Yeah, that makes sense. But the thing was, like, if we have 2 nodes, and if I'm draining both of those nodes, is there any kind of a validation mechanism, like Chaos will not allow us to run that, or it will throw us any warning, like if you will do that, that will not work, something like that? So yeah, I think.
Yeah, that's good feedback. Right now that's not available, but that's something we can definitely consider.
Okay.
Thank you.
Right, thanks Abdul, thanks Karthik and Shubham for the great demo and answering the questions. If you have any other questions, feel free to post them on chat. Without any further ado, I would like to invite Akash. We'll be talking about the agent help. Akash, the floor is all yours.
Thank you, Prithvi. So hello everyone, I'm Akash and I'm a co-contributor to Litmus and also software engineer at Harness. So today I'll be going through to present and give a demo on installation of Litmus agent using Helm charts. So this is something that has been made available with this release with beta 3 Litmus 3.0 beta 3 release. So I'll just going to share my screen now. Yeah. So basically, this will help everyone to install the Litmus external agent to any cluster using the Litmus Helm, using the Helm chart approach. So if you go to the Litmus Helm repository, you can find it in the README in the steps to install. So it's a very basic command, where you can feed in the values according to your requirement and then run it, and that will basically install it. So I have a Litmus Chaos Center running Litmus 3.0 beta 3 version. So I already have this running, and I have the self agent running here. So what I'll do through in this demo is basically give you a walkthrough about the tunables available here in this command, and as well as show you the installation process on the same cluster here. And go ahead and run the pod delete experiment and complete this demo with that. So let's just get started about the command that we have here. So here we just like this command will basically have these tunables available here. So we have two modes available. One is the namespace mode, and one is the cluster mode. So in this I will be going through and installing it using the namespace mode for this demo, but you can also install it in using the cluster namespace cluster mode. So here, first of all, you need to mention the namespace in which this specific agent is going to be installed. And if that namespace is not present, then you can add this add this flag value to create that namespace. Then after that, you have the agent name, agent description, which will be shown in the UI. And after that, then you have the Litmus URL, Litmus backend URL. So if you are going to install this on a separate cluster, suppose like I have Litmus running on one cluster and want to install this agent on another cluster running somewhere else. So I can provide the URL, abstract URL for that specific cluster here for the Litmus URL, and the Litmus backend URL, which is the server Litmus server URL that is present. So here I can provide it here with the port value. So that will basically give me access to Litmus front-end, Litmus backend services for the agent to run. If you are going to install it on the same cluster that where the Litmus is running, which we'll be doing for this demo. So for that, you can provide the service name path here with the port name, and same for the Litmus backend URL. So according to your use case, you can either provide the path for the same cluster for any other cluster if you want to install it for. Then the Litmus username and password is basically what you use to log into the front to the Chaos Center, and the project ID for which you want to install this specific specific agent for. The agent mode is basically, you can define whether we want to install it for the namespace mode or for the cluster mode. So for this, we will be installing it in the namespace mode. And since we're installing it on the same cluster, so we already have the CRDs and the workflow controller CRDs present. So we can use these flags to set these flags as false, so that it does not reinstall the same CRDs again. Or and if you're installing it in any separate or any other cluster where you need to install the CRDs, then you do not need to provide the specific these flag variables here. Same with the cluster as well. You can see they also have the same flags as with this thing, but the only difference is like we do not provide these as false because probably the cluster wouldn't have the CRDs already installed in them. So these are the flags that are available for this command. And you can find it here in the Litmus Helm repository in the README file itself, installing under the install external agent section. So this has been made available with the Chaos Center 3.0 beta 3 version onwards. So I'm running this specific version right now. So let's start off with the installation part. So I have the command set up here already. So basically I have provided the because I'm running in the same cluster, so I provide the service path name here and the backend service Litmus server path name here as well. And I'm installing it in namespace mode. And this is a project ID, so I got it from Chaos Center. You can just go ahead and click on copy, and this will just copy the project ID for whatever project you are running it on. So I got the project ID from there and pasted it here. So this basically will go ahead and install it. One more thing, like if you already had added, first of all, you will have to go ahead and add the Litmus repo on the Helm chart list. So you can do it using this command, Helm repo add Litmus chaos. And if you have already added it and it's like you haven't updated, so you can just go ahead and do the Helm repo upgrade to update it so that you don't have any installation issues in installation. Yes, so I have done all these steps. So I'll just go ahead and run it here. So it will take around a minute or two. So it will take a minute or two to install it. So I have this here. I'll just check the namespace. Okay, so it's installing right now. So once that namespace, yeah, it's created. So one more thing I'll do is basically install an Nginx service. So we can run the pod delete experiment after this is installed. So I have a manifest ready for it. Yeah, so it has been deployed now. So you can see the pods coming up on this namespace. Yes. So I just see the subscriber logs to verify. So yeah, the subscriber is getting up. So I can go ahead and check in the kiosk center in the delegate. So you can see the agent is in pending state. So once the subscriber starts properly, then it will get into active state. Meanwhile, I'll also go ahead and install the Nginx service so we can yeah. So I have an Nginx pod running here on which I'll be running the okay. Yeah. So I guess the subscriber is up. So we can see, yeah, so the agent is active now. So I'll just go into chaos scenarios and schedule a chaos. Yeah, so I can see the Helm agent is active here. Go ahead and select the pod delete experiment. Right. And I'll put it on Litmus agent and app Nginx. Yeah. So it's just basic. I won't be adding any probes or anything else. I'll just make it so it's only one iteration. And that's it with this. And I'll just go ahead and schedule this and run this for now. Okay. So we have this starting up here, and we'll be seeing this coming up. So it's now installing the experiment. So yeah. Basically, this is another way you can install the Litmus agent rather than using the Litmus detail. You can use it if you have any help installation for Litmus. You can use it to install the agent as well for now. Okay, so we have the workflow starting up now. Okay, so we have the pod delete runner pod coming up. Yeah, and the experiment pod as well. So we will now see this Nginx pod getting terminated. Yeah. So yeah, and got terminated and got started again. So basically, like this shows like the agent installation was successful, and as well as we can run experiment on this here. So you can use the same method. You can go through the README file and check out how to install it in a separate in cluster mode or as well as installing it in a separate cluster. Just you need to take care of this Litmus URL, Litmus backend URL values according to your type of installation. And for cluster, you need to take care of these VRD creation values. So that's it. If anyone has any question regarding this installation, you can take them up.
Just to add to what Akash has been showing, one of the significant benefits of this Helm chart is now you can create chaos enabled clusters. So in case you plan to do chaos experiments on transient environments that you're bringing up probably as part of pipelines, etc., you can automate the setup of agents on those clusters even as you bring them up, or you can even do this as part of your Terraform templates, etc., so that you're already bringing up an environment on which you can readily run chaos. So that's one of the advantages of doing this. Of course, not to mention the fact that if people are more used to Helm, and you'd like to use that to bootstrap clusters, both control plane, execution plane, etc., as part of a Helm file. So that's also another use case.
Thanks, Akash. Thanks, Karthik. Do we have any questions on the floor?
I see a question on chat from Raj on the release date for 3.0. So Raj, at this point, we would like to gather more feedback from users on the effectiveness of our 3.0 beta, the new changes that are coming in. And there is a discussion thread on the main Litmus repository. Let me probably share the link for that. We've outlined some capabilities which we believe are important for the major version upgrade. Some of those have already been addressed. Running a single helper pod for nodes, irrespective of the number of application replicas, that's achieved. There is the agent Helm chart, which Akash just showed. There are a few other enhancements that we plan to make available as part of the beta program. So we will try to introduce these features, gather feedback around their effectiveness, and then put 3.0 out, the general availability out. So it's something that we're looking at least a couple of quarters down the line. Having said that, it all depends upon what the community needs and what the community is driving towards. So yeah, I think that's probably a rough estimate.
Right, thanks, Karthik. Do we have any other questions on the floor? Maybe based on Akash's talk or generic to Litmus Chaos? Right, I guess we have none. So perhaps with this, we come to the end of today's community call. I saw another new member joining in, Asim Sagar. Asim, would you just like to introduce yourself to the community and let us know your progress on Litmus? Yes, we are not able to get any response from Asim right now. All right, folks, thank you so much for tuning in. I think we'll end this call early today. And once again, thank you so much for joining the Litmus Chaos Community Sync-up call. We'll see you next month, again on 3rd Wednesday of February, for another edition of the Litmus Chaos Community Sync-up call. Until then, take care of yourself, and thanks again for joining in. Thank you, everyone.
Thank you so much.